diagrams from start to finish. So it's going to be a little bit longer lesson. This week we're going to have slightly longer lessons just so that we're in a good position to split at the end of the of next week. So regulars and IBs are going to be splitting into two different groups. So let's just do a quick review of drawing Lewis diagrams for substances. Okay, this is using the method that we talked about yesterday, where you count up the valence and you stick them on the dots on the compound. SO, so how many valence does that have? Sulfur has 6 valence each, oxygen has 6 valence each, so I have 12 electrons. Now, when you have 2, which one is your central atom? The answer is, it doesn't really much matter. There is no central atom. So I'm just going to write it like this, and then I'm going to link them up with a bond pair. That means I have 10 electrons left. So I have to fulfill the octet. So let's see here, 2, 4, 6. Okay, I got 4 electrons left. 2, 4, I've run out of electrons. So how do I make this work? How do I make oxygen have 8 electrons? Right, like if I draw my little circle checker and I bring it over oxygen, how many electrons does oxygen have? It's got 6 around it. Sulfur has 8. If you remember the steps from yesterday, when you've run out of electrons, you can share, it doesn't matter where you share it from, you can share another bond pair. That allows a double bond to form. So then I get something that looks like this. And if I check around it, it works. Everything has 8 electrons. Okay, carbon dioxide. Let's add up our electrons. Carbon has 4 electrons. Oxygen has 6, but there's 3 of them, so that's 18. We've got 2 negatives, so we have 2 more electrons than normal. We have 24 electrons. Which element is probably in the middle? It's probably carbon, so let's make this as symmetrical as possible. Okay, let's link everything up. 2, 4, 6. Okay, I've got 18 electrons left. Now I have to fill the peripheral in. So oxygen needs to have 8 around it. 2, 4, 6, 8, 10, 12, 14, 16, 18. Okay, that works good. But does carbon have 8 electrons around it? Let's check. Does carbon have, oh, that's not big enough. Does carbon have 8 electrons? No, it's only got 6. Oxygen has 8. Oxygen has 8. Oxygen has 8. So how do you make sure carbon has 8? You're going to have to borrow a bond pair. Now, in this case, it doesn't really much matter where we steal it from, because molecules are going to be flipping around in 3D anyways. So we're trying to represent something in 2D that is actually 3D. So when I redraw this, there's going to be a double bond there. Now, because this is an ion, I should put it in brackets. I think I forgot to tell you guys that yesterday. Now, I could have decided to steal the electrons from here. That's okay. I could have decided to steal the electrons from here. It doesn't matter. It doesn't matter, because you could just flip this thing around. It would be the same in 3D no matter where you're looking at it. Okay, last little bit of review. This one's a little bit tougher down at the bottom there. If you see a bigger molecule, try to build it the way that it's shown. So before I add up the electrons, I'll show you what I mean. So we've got carbon, and then it's got 3 hydrogens. And remember, we talked about hydrogen can't bond to anything but one substance. So it probably looks like this. Then we have an oxygen and a hydrogen attached to that oxygen. So let's add up our valence. Carbon has 4, each hydrogen has 1, oxygen has 6, hydrogen has 1. So when I add this up, I get 14 electrons. Okay, let's link everything up. 2, 4, 6, 8, 10. All right, I've got 4 electrons left. Where do you think they go? They go around the oxygen. Perfect. Okay. Now, the dot stuff is, the online learning doesn't do great at this, because we sit in class and we practice this for a week. So you guys are going to be basically listening to me talk and then practicing 2 or 3 of them on the assignment this week. So it's not the same. What we're going to move on to now is structural diagram. I'm going to spend a little bit longer on structural diagrams because you need this for Chemistry 30. What structural diagrams do is they take the dot diagram, the Lewis dot diagram, and they turn it into where bonds are. So for example, if I had NCl3, I'm just going to do this real quick. This is what the Lewis dot diagram for NCl3 would look like. Now, in chemistry, the peripheral lone pairs around the chlorine and the lone pair up here around nitrogen doesn't really affect the structure. It affects the shape, which we'll get into on Wednesday. But what this turns into is something that looks like this. And you can keep the dots there if you want. You don't have to. But all of the peripheral dots go away. And any dots that connect the bond pairs become a single line. It's amazing. That's a structural diagram. Now, you can always go from a Lewis to a structural diagram to figure out the structural diagram, but there's a whole bunch of shortcut cheats that I'm going to go over with you guys. Okay? So, hydrogen and every other element that only has one valence electron can only have one line drawn to it. What does that mean? Well, if we think about hydrogen's Bohr diagram, all it has is one electron, which means that its shell can only contain one more shared electron to bring it up to 2. The same thing goes for things like sodium. Sodium is element 11. It's got 2 in the first, it's got 8 in the second, and it's got 1 in the outside electron. So it only has one valence electron. You can only have one line to sodium. Okay? Now, if you want to think of the periodic table, I'm going to redraw the periodic table really bad right now. So here we go. There's there's a set of rules we can go through. Is that group 1 only has one line to it. Group 2 only has 2 lines to it. Then we go to group 13, but if we subtract 10, that's actually group 3. Group 3, it's actually just boron, and maybe aluminum. It has 3 to it. Then group 4, group 5, group 6, group 7, and then group 8 has nothing because noble gases don't bond. Now, that's the valence electrons. The bonds change a little bit, right? So this is the valence electrons. This is the bond. The number of sticks that you'd get is 1, 2, 3, 4, and then back to 1 again. 2, 3. And the reason why is that stuff in this column, like nitrogen, when we draw a Lewis dot diagram for nitrogen, even though it has 5 valence electrons, a lone pair takes up a spot. So it loses the ability to bond. That's why carbon gets 4 sticks. Carbon has 4 valence. 1, 2, 3, 4. Nitrogen has 5 valence. Phosphorus has, sulfur has 6. 1, 2, 3, 4, 5, 6. So even though sulfur has 6 valence, it can't bond 6 times. It can only bond twice because it only has 2 bonding electrons. So that's the shortcut over here. Okay, so hydrogen and hydrogen's column can only have 1 valence to them. Okay, beryllium and anything in beryllium's row like magnesium and calcium, they get 2 sticks. Boron gets 3 sticks. So boron will always look like this. Now, you can have a double bond. See this bad. You can have a double bond that counts as 1, 2, 3 sticks. Carbon always gets 4. Now, nitrogen, as you go back to the noble gases, it marches back down to 0. Nitrogen gets 3, as we talked about. Oxygen rows get 2, and halogens only get 1. So the halogens are like hydrogen's row. They only have 1 bond ability. Okay, noble gases get 0 because they don't bond. Now, polyatomics, like the carbonate ion, maybe that's a bad example, but other polyatomics, oh, here's a good one, like the phosphate ion. Any polyatomic doesn't follow this shortcut system because the electrons have been rearranged. They hold more electrons than they should. Okay, so let's just practice a couple using. Let's just practice the couple using. We're going to go from Lewis to structural, and then we're going to jump right to structural. Okay. So the perchlorate ion, just to make sure I get this right, perchlorate, Chlorate, perchlorate, yep. So the perchlorate ion looks like this. And if we add up our valence, chlorine's got 7, oxygen's got 6. There's 4 of those, so that's 24, plus an extra 1. So that's 25, 20, 32 electrons. Okay, so I've got 32 electrons to go. So chlorine is my central atom because it's in the least amount, and let's make it symmetrical. Link everything up 2, 4, 6, 8, and then fill up my peripheral. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Perfect. So I've run out and everything has 8 electrons. So what does the structural diagram for this look like? Well, we only worry about the things that are bonded. That's what the structural diagram looks like. Brilliant. Okay, what about ammonia? Or ammonium, which is NH4. Okay, let's add up our valence electrons. Nitrogen has 5. Every hydrogen has 1. There's 4. It's positive, so we subtract 1 from our total, so we have 8. Set this up symmetrically. Looks like this. 1, 2, 3, 4, 5, 6, 7, 8. Hey, I'm done. Perfect. This is an ion, so I'm going to put it in brackets. The structural diagram only shows the bond. Now, I did these first because these are ions. So we can't use the shortcut. You kind of have to do the Lewis diagram. But if you have things that aren't ions, you can use guess and test, and you can go right to the structural diagram. So let's take something crazy like C3H8. What would that look like? Well, let's set this up so it's kind of, put our carbons in a line, okay? And then let's surround them with hydrogens. What's that? 1, 2, 3, 4, 5, 6, 7, 8. Every hydrogen needs a stick. 1, 2, 3, 4, 5, 6, 7, 8. Does every carbon have 4 sticks? The answer is yes. Okay, what about C2H4? Okay, let's set this up kind of symmetrically. Okay, so 2 carbons. All right, so we've got 4 hydrogens, so maybe we'll stick the hydrogens over here. Okay, how many lines does hydrogen get? Only 1. Okay. How many lines does carbon get? Carbon gets 4 lines. So if we put 1 there, that doesn't give the carbons enough lines, right? That doesn't give the carbon enough line. It gives every hydrogen works, right? It doesn't give the carbons enough. So we have to put a double bond. All right, what about nitrogen? How many lines does nitrogen get? Remember from the slide previously? Okay, let's go back to it. How many lines does nitrogen get? Nitrogen gets 3 sticks. Why? Because it's got 3 bond pairs, or bonding electrons. So if we have 2 nitrogens beside each other and they need 3 sticks, guess what? Triple bond. Yeah, that exists. That's a thing. Okay, how about C2H2? All right, let's set this up symmetrically. Carbon, carbon, and a hydrogen on either side. How many sticks does hydrogen get? 1. How many sticks does carbon get? 4. So if I do that, that doesn't give me enough. But if I do that, that gives me 3. Like if I use my little ring thing here, make it a little bigger. I have 3. That's not enough, right? I need triple bond. So now the carbons work and the hydrogen works because it only gets 1 stick. Now, as you're building these, let's say like C2H2, if you're trying to build it a different way, like this, that's okay too. What's not okay is if you try to build it like this. Because guess what happens? As soon as you do that, this hydrogen has too many sticks. Hydrogens are always on the outside. They're not really bound to anything. Okay, so it's Monday. That's the lesson about Lewis to structural. You guys can now start the project for this week. There's about 20 questions on it. The first 5 are Lewis. The next 5 are structural. So you can tackle about half of the assignment this week. We're going to be touching on something new every day, and we're going to keep it simple, but this is a big deal to try and work your head around, drawing Lewis and drawing structural diagrams. Remember, an ion like PO4, 3 negative, you can't use the rule where phosphorus only gets 3 lines because it's an ion. If I was to draw the dots, the only way it would work is to put phosphorus in the middle like this, okay? And that's just how polyatomic ions work. So yes, in this case, phosphorus would have 4 lines to it, and oxygen would only get 1. So the rules fall apart. The rules fall apart for polyatomics. All right, that's the lesson for today, guys.